Hi everyone, I'm Veer Mahajan, and in this video I'm going to show you what geometric probability is. Geometric probability is basically the area of the successful region over the area of the total region, and I'm going to explain what that means. So let's say that you just have a flag, and this is just a very basic example, but things will get harder. So let's say that this is a flag, this is 3, this is 5, and right in the middle, and let me think. Okay, so from the midpoint over here, which is 5, until here, there's a red stripe, and then we're going to color that in red. What is the probability that if you throw a dot at it, you land in the red area, right? So this part is all red, and this one is a pretty basic example. See if you can figure it out on your own. What is the probability that you land in the red region instead of the rest of this area? And the probability, because this is the full height, this is 3, this is exactly half of it. It's 2.5 times 3 over 2, and this is just basically 5 over 2, so that's 5 over 4 times 3, so that's 15 fourths, and the total area is 15, so if you divide that by 15, you just get 1/4. So the probability that you land in this red region is 1/4. But this one is a pretty basic example, and things will get a lot harder after this. So let me give you the first problem. This is just a practice problem, so I'm not really going to count this. But let's say that we have a lot of concentric circles. Let me just draw them. Oops. So we have one circle here. The small circle has a radius of 1, and let me make it a bit smaller then. And each circle has a radius 1 more than the circle smaller than it. So that's one circle, 2, 3, 4, and 5. So that's 5 circles. And what is the probability that if you throw a dot at this thing, just what that it lands in this third circle? And this one is a bit harder than the other one because you need to now figure out this area, and it's not the full circle because there are 2 circles being subtracted from it. This one actually isn't so hard. If you just try to figure out how you can get this area, then find the total area. And remember, this has a radius of 1, and since there are 1, this one is going to have a radius of 2, 3, 4, and 5. So we can just find the total area, right, because it's the area of success. And I won't write area in brackets because that's how you write area, so let me just do that. Area of success over the total area. What is the total area in this case? This is 1, 2, 3, 4, 5. So since the area of a circle is pi r squared, here we have r equals 5, we get 25 pi, right? Because 5 squared times pi equals 25 pi. So we have some area, this blue area, let me just write that, over 25 pi. So let me just quickly color it in. We know that this circle, this entire circle, including these parts inside, has an area of 9 pi because the radius is 3. So 3 squared times pi equals 9 pi. However, this part is being removed, and this is just one circle, right? This big circle over here being removed. And that circle, this white circle which isn't included in this, that circle has an area of 4 pi because this radius is 2. So 2, so that's 9 pi, which is this total circle minus that smaller, minus this circle over here, that's 5 pi because it's 9 pi minus 4 pi, which is 5 pi. So this total success region is 5 pi. So let me now edit that and fix that. That's 5 pi out of 25 pi. That can be simplified. You can cancel out the pi's. So you get 5 over 25, which can be simplified when you take out a 5 from both sides. That's just 1/5. And this one is also pretty similar to the first problem. It's just finding a little area out of something else. But the next one is actually a word problem. So let me just read it aloud. A point is chosen on a coordinate plane such that both its coordinates are between 0 and 3. What is the probability that the point is less than 2 units from the origin? The origin is just the point 0, 0. So let's just draw that, and then I'll read out the question again. So let's just draw this graph right here. So that's 0, 0. Since both of the coordinates are between 3, this one is now 3, 0. This is 0, 0. And a bit further up here, there's 0, 3. And then I'll put an extra mark here for 0, 2. And I'll just put one more here for 0, 1. So these are all the points that we have. This is 1, 0. It might be a bit hard to see, but you should get what I'm doing here. 1, 0 and 2, 0. So these are all the points, and we want our circle, not a circle, sorry. So basically, just imagine this again as someone throwing darts over here. So this is the total area where they can throw darts. All the possible areas are encompassed over here because they're between 0 and 3, both the coordinates. So they have to be between these, like 0 and 3 here, because that's all the way 3. This is 0. So it has to be between that, and from here to here, between those. So this is the total white area in this box that matches all those criteria. What is the probability that the point is less than 2 units from the origin? Well, this is the origin, so let me just write that, origin, because that's just the point 0, 0. And if it's 2 points away from here, what shape would that be? If you said triangle, it's actually wrong, because it's actually a semicircle. Because a semicircle, the definition of a circle is that all the points on it are the same amount of units away from the center. So let this be the center, that's 2 units away, so we need another point here. So it's just basically this. It's not exactly a circle, obviously, because it's only 1/4 of it, so it's a quarter circle, right? That makes sense. I hope. If it doesn't, then just I can explain it again. Basically, in a circle, all points are an equal amount away from the center of the circle. Like all points on the circle, on the circumference, are an equal amount away from the center of the circle, and that's the same over here. All of these points need to be less than 2 away from this point. Imagine that the circle is fully around the entire thing. All of them would be less than 2 points away from the center. And here, since we're just limiting it to this area, it's just this quarter circle. And now we just need to find the area of this quarter circle. So let me just highlight that in blue, kind of just a scribble inside. We need to find the area of, again, success over the total. Now what is the total area over here in this shape? Right, we've drawn it now as a shape. Just imagine that again, this is a dartboard. You need to throw it in this. What's the chance that you throw it landed in this bluish area? Well, the total area, this can just be thought of as a rectangle, right? This entire length is 3. Not a rectangle, a square actually. This length is also 3. So then, wait a second. The area is 9, right? We can just treat this as a rectangle. So, something over 9, our area of success over 9. What is this area? Well, this formula for a circle, again, this is also in the last problem. It's pi. Okay, let me just erase this part now. I'll just erase these coordinates since now you have done with that, and all of this. I'll just keep this figure over here. So the area of a circle is pi r squared. Over here, the radius we saw was 2, right? Because it's 0 to 2. This length is 2 out of the 3 of the circle, and we're doing it in terms of how many units are in the circle. That's why we made this 3. So that's 2. So that's pi times 2 squared. This is 4 times pi, so that's 4 pi. However, that's not actually correct, because even if you just think about it logically, this is just a quarter circle. But if you calculate this, pi is roughly 3.14. 3.14 times 4 is completely different. It's 12.56, and that's a lot more than 9. Probability has to be between 0 and 1. I probably should have mentioned that earlier, but it has to be between 0 and 1, and 12.56 over 9 is a lot more than 1. So it's not, that doesn't work. It's actually a quarter of a circle, right? Because that would be the area of this entire circle. But since this is only, the circle would be a bit smaller, I've just drawn it wrong. But this is only a quarter of the circle, so the area will also be a quarter of this area, which is just pi, right? It's 4 pi over 4, which just becomes pi in the end. So we have now an area of pi over 9. And let's just check this to see if it seems realistic. So what is pi? Let's just say pi is 3.14, that's close enough. So that's 3.14 over 9, which is roughly 1/3, which seems to make sense because this does look like it takes up about 1/3 of this total area. Okay, now let's go on to another problem type. And this one is also pretty similar. You just have to, they don't give you a shape. You have to kind of visualize it and draw it out for yourself and then figure it out. But this one is just, it's a bit harder as well. Even harder than this one. So let's say that Joe needs to catch a special bus, and there's a lot of traffic, so the bus can come anytime between 4 and 5 p.m. However, he doesn't know when it's coming between 4 and 5 p.m. But when it comes, it's going to stay there for 20 minutes to wait for him to come. What's the probability if he comes anytime between 4 and 5 p.m. that actually waits for 10 minutes, not 20 minutes, just 10 minutes. what's the probability that if he reaches between 4 and 5 p.m. that he misses the train? And I'm going to write that over here because that could get important later. Misses. Okay, so how will we draw this? Well, we can try to do what we did in the last one and just draw a square. And let's just draw this. Okay, let me get another color because we've used blue this entire video. And I think it might be running out a bit. Yeah, this looks good. So let's just make another thing. And let's call this Joe. And this the bus. And now we can represent all the times at work. Okay, so wait, now let me fix this to 4 p.m. So 4 p.m. This is 5 p.m. Right? So Joe can reach any time between this, and so can the bus. This is also 5 p.m. If the bus reaches at 4 p.m., it's going to stay until 4:10. Right? Okay. And now let me just actually fill it in. I'm not going to write 4:10 each time. I'm just going to write how many minutes have passed since 4 o'clock. If the bus reaches at 4 o'clock, it's going to stay for 10 more minutes. So it's going to stay all the way until 4:10. Which means that Joe can stay any time over here. Right? He can come anytime between 4 and 4:10, and he's going to catch the bus. Okay, so let's just draw that over here. It's a bit hard to see, so I'll just use another color for that, so that you can see that this works. So right here, this is a possibility. And then if he comes at 4:10, if the bus comes at 10, then Joe can come. It's going to stay again for 10 minutes, right? It's going to stay from 4:10 to 4:20, which is this part, right? This is 4:10, 4:20. So Joe has to come at some time over here. And if the bus comes at 4:05, lands from 4, stays from 4 to 4:15. So Joe can come from 4:05 to 4:15, which is over there. And similarly, we'll just shade in all of these points here because they all work just like that. Okay, let's keep on going. At 20, if the bus comes at 4:20, then Joe has to be there from 4:20 to 4:30 because that's when the bus is going to stay, and so on. I think you can see the pattern now. It looks like this. It's just a line that goes like that. So let's just finish this square so that it's a bit easier. And now the rest of my drawing won't be too exact, but I'll just try my best to make it as accurate as possible. If you want to check it, let's just test a few points over here. If the bus comes all the way over here at 5 o'clock, Joe has to come at 5 o'clock to catch it because he isn't coming after 5 o'clock. He's coming anytime between these two times. If it comes at 4:55, which is around here, then he can come from anytime 4:55 to 5 o'clock because again, he's not going and staying until 5:05. So this graph is definitely clear. This is the success that he catches it in, but it says misses. So what we actually have to find is just this area plus this area. Basically 1 minus this area, which is going to be the same as this area plus this area. So let's now find the area of this white triangle over here and this white triangle over there, and then that's going to be equal to the probability that he misses. So because it's misses, this is actually the opposite. So this is the probability of fail, right? He fails to get the bus over the total. So let's quickly calculate that. This, and again, we're just going to do it in terms of this area with this length being 1 and this length also being 1. So the total area is 1. So the total is 1. And this has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 parts. And only 5 of them are over here. Right? And same here. It ends over here. So there are only 5 sixths over here. So this has an area of 5 over 6 times 5 over 6. But that's not actually accurate because it's the area of a triangle is base times height. Base is 5, 6, height is 5, 6 over 2, which is equal to, let me just continue over here, 25 over 36 over 2. So that's 25 over 72. So we have 25 over 72. Over here, what is this area? Well, that's a full 1. That's also 1 because this part just is full entire length, same there. So that's going to have an area of 1 times 1 over 2, which is 1/2. And if you add that 1/2, let's just put this now into terms of 72. Let's just get the same common denominator. So we have 36 over 72. Let me continue down here. 25 plus 36, that's 61, I think. Is that right? Yeah, 61 over 72. So this is a chance that he doesn't meet the bus. And what's left, so 1 minus 61 out of 72 is a chance that he does meet this. But what we were looking for is just the probability that he misses the bus, and that's 61 out of 72. So I hope you understood all of these different question types. I hope that you do check out the practice problems that I have on my website, and if you do, you hopefully will get them correct and understand this. Thank you for watching. If you haven't already, please consider subscribing this video, subscribing to my channel, and also liking this video. If you know other people who might be interested in geometric probability or who haven't heard of it, please consider also sharing the video with them. Thank you for watching. Bye.